Hello, in this lecture we will find the radius of a circle enclosed in a triangle. As you can see in the drawing, we have a triangle ABC with side AB that equals to 4 units. Side BC of triangle ABC equals to 3 units, and the side AC of triangle ABC equals to 5 units. And we also know that the area of triangle ABC equals to 6 units squared, and we want to find out the radius of the circle that enclosed in this triangle. Okay, so first of all we will define the center of the circle as point O. Point O is the center of this circle, and then we will define the touching point between side AB of the triangle and the circle as N. So N is the touching point between side AB of the triangle and the circle. Or we can also say that side AB of the triangle is tangent to the circle at point N. Okay? And we will define the touching point between side BC of the triangle and the circle as M. Again, point M is the touching point between side BC of the triangle and the circle. And we can also say that side BC of the triangle is tangent to the circle at point M. And then we also will define the touching point between side AC of the triangle and the circle as P. Again, P is the touching point of side AC with the circle, or we can also say that side AC is tangent to the circle at point P. Okay? In the next step, we will connect together by a straight line points N and O. So actually line segment NO is the radius of this circle, because line segment NO starts from the center of the circle, that is to say from point O, and ends at point N, that is a point on the circle itself. For that reason, line segment NO is the radius of the circle. I will mark it as small r. And we will also connect together points O and M by a straight line. So actually line segment MO is also the radius of this circle. Line segment MO is the radius of this circle because it starts from point O, the center of the circle, and ends at point M, that is a point on the circle itself. For that reason, line segment MO is the radius of this circle. I will mark it as small r. Okay, and we will also connect together by a straight line points O and P. Okay, line segment OP is the radius of this circle because it starts from the center of the circle and ends at point B, that is a point on the circle itself. For that reason, line segment OP is the radius of this circle. Okay, in the next step, we actually have a rule. I will mark it as rule number 1. Rule number 1 states that in any circle a radius and the tangent to that radius are perpendicular to each other. I will read rule number 1 again. Rule number 1 states that in any circle, a radius and the tangent to that radius are perpendicular to each other. So, actually, if we have a radius, let's call it R, and we have tangent to that radius, let's call it T. Then the radius is perpendicular to the tangent. That is to say, this angle is 90 degrees and this angle is also 90 degrees. Okay, so in any circle, a radius and the tangent to that radius are perpendicular to each other. Okay, so actually we can implement this rule on our circle because we have 3 radiuses and 3 tangents to those radiuses. So actually, if we look at radius, a line segment NO that is a radius of the circle, actually the side AB of the triangle is tangent to this radius. For this reason, actually the radius is perpendicular to the tangent. That is to say, angle ONA equals to 90 degrees and also angle ONB equals to 90 degrees. Because in any circle the radius is perpendicular to its tangent. That is to say, this angle is 90 degrees and this angle is also 90 degrees. Okay, and in the same way, we actually can look at line segment MO, that is the radius of this circle, and we have side BC of the triangle that is tangent to this radius. For this reason, according to rule number 1, the radius is perpendicular to its tangent. That is to say, angle OMB equals to 90 degrees, and also angle OMC equals to 90 degrees. Okay, and we can look on line segment OP, that is the radius of this circle. We have side AC of the triangle that is tangent to this radius. So actually, according to rule number 1, angle OPA equals to 90 degrees, and angle OPC also equals to 90 degrees, because the radius is perpendicular to its tangent. That is to say, this angle is 90 degrees and this angle is also 90 degrees. Okay, so in any circle, a radius and the tangent to the radius are perpendicular to each other. Okay, that is rule number 1. Actually, a general formula for the area of any triangle is actually the base of the triangle times the height to the base divided by 2. That is the area of any triangle. The formula for the area of any triangle. Again, the formula for the area of any triangle equals to the base of the triangle times the height to the base divided by 2. Okay, or we can also, instead of the area of triangle, we can use capital A, abbreviation for area, and we can say that A equals to the base of the triangle times the height to the base divided by 2. Okay, so the base times the height to the base divided by 2 is actually the formula for the area of any triangle. Okay, so we actually can implement this formula before that we will connect together points O and B by a straight line. And we will also connect together points O and C by a straight line. And we will also connect together points O and A by a straight line. So now we can use the formula for a triangle in order to find out the area of triangle OBC. Okay, so we actually want to find out the area of this green triangle, and in order to find the area of the green triangle, we use the formula for the area of any triangle. So actually the formula for the area of the triangle, the green triangle A, abbreviation for area, A equals to the base of the triangle. The base of the green triangle is 3 units, times the height of the green triangle equals to the radius, because the radius creates 90 units with the base. Actually, angle OMC equals to 90 degrees, and also angle OMB equals to 90 degrees. And the height of a triangle is defined as the line segment that creates 90 degrees with the base, or the line segment that is perpendicular to the base of the triangle. So actually the radius of the green triangle, the height of the green triangle is the radius of the circle. So the area of the green triangle equals to the base, that is 3 units, times the height, that is the radius, divided by 2. Okay, again, the area of the green triangle equals to the base of the triangle, that is 3 units, times the height, that is the radius, divided by 2. 3 over 2 is 1.5. So I will write it down. Okay, so the area of the green triangle equals to the base of the triangle, that is 3 units, times the height, that is the radius, divided by 2. Or 3 times the radius divided by 2. 3 over 2 times r equals to 1.5 times the radius. Because 3 over 2 equals to 1.5. So the area of the green triangle equals to 1.5 times the radius of the circle. Okay, and in the same way, by using the formula for a triangle, we will find out the area of triangle AOC. Okay, we will find out the area of the yellow triangle, triangle AOC. Actually, the area of triangle AOC equals to the base of the triangle, that is actually 5 units. It is given us in the question. times height, the height, the height of the yellow triangle equals to the radius of the circle, because the radius creates, the radius is perpendicular to the base of the triangle. For that reason, the radius is the height of the yellow triangle. So the area of the yellow triangle equals to the base, that is 5, times the height, that is the radius, divided by 2. Okay? The area of the yellow triangle equals to the base of the triangle, that is 5 units, times the height, that is the radius of the circle, all divided by 2. 5 over 2 equals to 2.5. So I write it down. So the area of the yellow triangle equals to 2.5 times the radius of the circle. Because 5 over 2 equals to 2.5. Okay? And in the next step we will find out the area of triangle AOB. Okay? We actually will find out the area of the orange triangle. So we will find out the area of the orange triangle according to the formula of the area of the triangle, that is the base of the triangle times the height divided by 2. So the base of the orange triangle equals to 4 units. It is given us in the question. The base times the height of the orange triangle is actually the radius, because the radius is perpendicular to the base. The height of the orange triangle is the radius, because the radius is perpendicular to the base of the orange triangle. Okay, so it is 4 times the radius of the circle, all divided by 2. 4 over 2 equals to 2, so in total we got that the area of the orange triangle equals to 2 times the radius, because 2 over 2 or 4 over 2 equals to 2. So in total we have 2r. The area of the yellow triangle equals to 2 times the radius of the circle. So we actually found out the area of the green triangle, that equals to 1.5 times the radius. The area of the yellow triangle, that equals to 2.5 times the radius, and the area of the orange triangle, that equals to 2 times the radius. Okay, so in the next step, we actually know that the area of triangle ABC equals to the sum of the areas of the green triangle plus the area of the yellow triangle plus the area of the orange triangle. Okay, so we write it down as a question number 1. The area A, the abbreviation for area of triangle ABC, equals to the area of the green triangle, that is 1.5 times the radius, plus the area of the yellow triangle, that equals to 2.5 times the radius, plus the area of the orange triangle, that equals to 2 times the radius. Okay, so Equation number 1 states that the area of the big triangle ABC equals to the sum of the areas of the green triangle plus the area of the orange triangle plus the area of the yellow triangle. Okay, so the area of triangle ABC, the big triangle, equals to the area of the green triangle, that is 1.5 times the radius, plus the area of the yellow triangle, that is 2.5 times the radius of the circle, plus the area of the orange triangle, that equals to 2 times the radius. Okay, so in total, in this side of the equation, we have 2.5 times the radius plus 1.5 times the radius plus 2.5 times the radius equals to 4 times the radius, and 4 times the radius plus 2 times the radius equals to 6 times the radius. So we can write down that the area of triangle ABC equals to 6 times the radius of the circle. Okay, so according to equation number 1, the area of triangle ABC equals to the sum of the areas of the yellow triangle plus the green triangle plus the orange triangle, and the sum of the areas of those three triangles is actually 6 times the radius of the circle. But we have already know that the area of triangle ABC equals to 6 units squared. Okay, so we can substitute the area of triangle ABC by 6. Okay, so we know that according to what is given us in the question, that the area of the triangle ABC equals to 6 units squared. It is given us in the question. Okay, we know that the area of triangle ABC equals to 6 units square, so we can substitute the area of triangle ABC in the first equation by 6. Okay, and we'll get that the radius of the circle equals to 1 unit. Okay, we substituted the area of triangle ABC by 6 because the area of triangle ABC equals to 6 units. So we got that 6 times the radius equals to 6, the area of triangle ABC. We divided equation number 1 by 6, and we found that the radius of the triangle is 1 unit. Okay, now I will summarize the lecture. We actually wanted to find the radius of the circle that enclosed the triangle ABC. We know that side AB of the triangle equals to 4 units, side BC equals to 3 units, and side AC equals to 5 units. And we want to find out the radius of this circle. Okay. Okay, and we actually define the center of the circle as O. Point O is the center of the circle. Then uh, the side AB is tangent to the circle at point N. Side BC of the triangle is tangent to the circle at point M, and side AC of the triangle is tangent to the circle at point P. We connected together points N and O by a straight line. Actually, NO is the radius of this circle because it starts from the center of the circle and ends at point N. It is a point on the circle itself. For that reason, line segment NO is the radius of the circle, and same thing applies to after we connected points O and M together by a straight line. Actually, OM, the line segment on OM, is the radius of this circle because it starts from the center of the circle and ends at point M, that is a point on the circle itself. And we also connected together by a straight line points O and P, and actually line segment OP is the radius of this circle because it starts from the center of the circle, point O, and ends at point P, that is a point on the circle itself. For that reason, OP is the center of this circle. For that reason, a line segment OP is the radius of this circle. Okay? And in the next step, we connected together points O and B by a straight line, and we were also connected together points O and C by a straight line. And we connected together points O and A by a straight line. Okay. Actually, we have rule number 1 that states that in any circle, a radius and the tangent to that radius are perpendicular to each other. So, if we have a radius that is R and the tangent that we called it T, then the radius is perpendicular to each tangent. That is to say, this angle is 90 degrees and this angle is also 90 degrees. So we actually can implement this rule in our circle because we have radius NO, and we have tangent to that radius at the side AB of the triangle. For that reason, according to rule number 1, the radius is perpendicular to the tangent, that is to say angle O and A equals to 90 degrees, and also angle O and B equals to 90 degrees. Okay? And in the same way, we can say that this radius, we have tangent to this radius, that is side BC of the triangle. For that reason, according to rule number 1, angle OMB equals to 90 degrees, and also angle OMC equals to 90 degrees. Okay, and in the same way, we can say that the side AC of the triangle is tangent to the circle at point P, and it is also tangent to the radius at point P, and for that reason, according to rule number 1, angle OPA equals to 90 degrees, and also angle OPC equals to 90 degrees. Okay, so actually we have also the formula for the area of any triangle. The formula for the area of a triangle equals to the base of the triangle times the height to the base, all divided by 2. This is the area of any triangle. Okay, so according to this rule, we can calculate the area of the green triangle, the area of the green triangle will be equal to the base of the triangle, that is 3 units, times the height of the green triangle. The height is the radius because the radius is perpendicular to the base. So the area of triangle, the yellow triangle, equals to the base of the triangle, that is 3 times the radius divided by 2, or the area of the green triangle equals to 1.5 times the radius. And then we can calculate the area of the yellow triangle. The area of the yellow triangle equals to the base of the triangle, that is 5 units, times the height, that is the radius, all divided by 2. Or we got that the area of the yellow triangle equals to 2.5 the radius, because 5 over 2 is 2.5. Okay? And we also calculated the area of the orange triangle. The area of the orange triangle equals to the base of the triangle, that is AB, equals to 4 units, times the height to the base divided by 2. Okay, so the area of the green triangle equals to the base of the triangle, that is 3 times the height, that is the radius, all divided by 2. Or the area of the green triangle equals to 1.5 times the radius. In the same way, we can calculate the area of the yellow triangle. The area of the yellow triangle will be equal to the base of the triangle, that is 5 units, times the height of the yellow triangle, that is the radius of the circle. Again, because the radius creates 90 degrees with the circle. Okay? So actually the area of the yellow triangle will be equal to the base of the triangle, that is 5 units, times the height, that is the radius, all divided by 2. Okay, 5 over 2 equals to 2.5 times the radius. So this is the area of the yellow triangle. Okay, so in the same way, we will calculate the area of the orange triangle. The area of the orange triangle equals to the base of the triangle, that is 4 units, times the height, that is the radius, all divided by 2. So it is 4 times the radius divided by 2. 4 over 2 equals to 2. So the area of the yellow triangle equals to 2 times the radius. But we also know that the area of the triangle ABC equals to the area of the green triangle plus the area of the yellow triangle plus the area of the orange triangle. Okay, so we can write down the equation. The area of triangle ABC will be equal to the area of the green triangle, that equals to 1.5 times the radius, plus the area of the yellow triangle, that equals to 2.5 times the radius, plus the area of the orange triangle, that equals to 2 times the radius. So in total we have in this side of the equation 1.5 to 2.5 equals to 4 radius. Okay, so in the total amount of this side of the equation is 1.5 plus 2.5 equals to 4, and 4 plus 2 equals to 6. So in total we have here 6 times the radius. So the area of the triangle ABC equals to 6 times the radius of the circle. But we have already know that the area of triangle ABC equals to 6 units squared. Okay, so we can substitute the area of triangle ABC by 6, and we can say that 6 times the radius equals to the area of triangle ABC. Okay, the total sums of the three triangles, the green triangle, the yellow triangle plus the orange triangle, equals to the area of the triangle ABC that contains those three triangles. So we actually can substitute the area of triangle ABC by 6, because it is equals to 6 units squared. Okay, and we got that instead we can substitute the area of the triangle ABC by 6, because the area equals to 6 units squared. So in total we will get that 6 times the radius equals to 6 units, and if we divide the equation by 6, then we can get that the radius equals to 1 unit. Okay, so this is the answer to the question. Now I will summarize the lecture. Okay, so the area, the radius of this circle enclosed in the triangle ABC equals to 1 unit. Now I will summarize the lecture. Actually, we wanted to find out the radius of this circle that is enclosed in triangle ABC. We know that side AB of triangle ABC equals to 4 units, side BC equals to 3 units, and side AC equals to 5 units. And the area of triangle ABC is given to us. The area equals to 6 units squared. Okay, we wanted to find out the radius of this triangle, the radius of this circle. Okay. So actually we define the center of this circle as point O, and then we connected together points N and MO by straight line, and in the same way we did connect the points O and M together, and we also connected points O and P together. And actually those 3 line segments equals to the radiuses of the circle, because of the fact that they all start from the center of the circle and ends in the circle itself. Okay, and as I've already said, 9 segments ON, 9 segment MO, and 9 segment OP are the radiuses of this circle, because they all start from the center and ends at any point on the circle itself. So it is defined as, they are defined as the area of the, they are defined as the radiuses of this circle. Okay, and we have rule number 1 that states that in any circle, a radius and the tangent to that radius are perpendicular to each other. So if we have radius and tangent to that radius, this angle is 90 degrees and this angle is also 90 degrees. So in any circle, a radius and the tangent to that radius are perpendicular to each other. So we can implement this rule in our circle, because we have radius NO and we have tangent to that radius, that is side AB of the triangle. For that reason, angle O and A equals 90 degrees, and the same in the same way we can say that angle O and B equals 90 degrees. And then we have also radius OM, and we have tangent to that radius, that is side BC of the triangle. For that reason, according to rule number 1, angle OMB equals 90 degrees, and also angle OMC equals 90 degrees. Okay, and we have also the yellow segment. We have radius, this radius and tangent to this radius. So according to rule number 1, angle OPA equals 90 degrees, and also angle OPC equals 90 degrees. Okay, according to rule number 1. Okay, so then we connected together points O and B by a straight line. We connected together points O and C by a straight line, and we connected together points O and A by a straight line. Then we actually have a general formula for the area of any circle. The area of any circle equals to the base of the circle times the height to the base, all divided by 2. Okay, so instead of area of a triangle, we can use the abbreviation for A, that is the abbreviation A is the abbreviation for area. So we can say that A equals to the base of the triangle times the height to the base, all divided by 2. In this way you can calculate the area of the green triangle. The area of the green triangle equals to the base of the triangle, that equals to 3 units, times the height. The height is the radius, all divided by 2. So the area of the green triangle equals to 3 over 2 times the radius. 3 over 2 is 1.5, so we have the area of the green triangle equals to 1.5 times the radius. Then we calculated the area of the yellow triangle. The area of the yellow triangle equals to the base of the triangle, that is 5 units, times the height, that is the radius, all divided by 2. So the area of the yellow triangle equals to 5 over 2 times the radius, or 5 over 2 equals to 2.5. And in total we got the area of the yellow triangle equals to 2.5 times the radius. And in the same way we calculated the area of the orange triangle. The area of the orange triangle equals to the base of the triangle, that is 4 units, times the height, that is the radius, all divided by 2, or it is 4 times the radius divided by 2 equals to 2 times the radius. And we actually know that the area of triangle ABC equals to the sum of the areas of the green triangle plus the yellow triangle plus the orange triangle. So we can write it, this equality, that the area of triangle ABC equals to the areas of the green triangle plus the area of the yellow triangle plus the area of the orange triangle. We wrote it in equation number 1. So equation number 1 states that the area of the big triangle, triangle ABC, equals to the sum of the areas of the green triangle plus the area of the yellow triangle plus the area of the orange triangle. The area of the green triangle is 1.5 times the radius, plus the area of the yellow triangle is 2.5 times the radius, plus the area of the orange triangle, that equals to 2 times the radius. So 1.5 times the radius plus 2.5 times the radius equals to 4 times the radius, and 4 times the radius plus 2 times the radius equals to 6 times the radius. So in total this side of the equation equals to 6 times the radius, and this is equals to the area of triangle ABC. But we have already know that the area of triangle ABC equals to 6 units. So we can substitute the area of triangle ABC by 6, and we will get the equation that 6 times the radius equals to 6. We will divide the equation number 1 by 6, and we got that the radius equals the radius of the circle equals to 1 unit. Okay? Thank you very much.